Okay, good morning, everyone.
Good morning, ma'am.
Morning, ma'am. Today we will start from the next chapter, waves and sound. So earlier in the earlier class, I told you that I will start from electricity, but then I thought that finishing the shorter chapters first. So we will start from waves and sound. So what is wave? Does anyone know what is wave? वेव क्या है किसी को पता है व्हाट इज वेव okay so basically wave is a disturbance from equilibrium position. Okay, wave is a disturbance from equilibrium position which travels. So equilibrium position means steady position. All the particles of the medium at rest, the steady positions. When there is no disturbance applied at the medium, that is equilibrium position. When a disturbance is applied to a equilibrium position, that is called wave. In other words, a wave is a disturbance that propagates through space and time, usually with transference of energy. So, propagates means it travels. A wave is a disturbance that travels. Okay, usually transference of energy means when the wave travel, they only transfer the energy. The particles of the medium do not travel from one place to another. The only the transfer of energy happens. The particles of the medium do not travel. This pattern, which move without actual physical transfer or flow of matters as a whole, called called wave. So this is the definition of wave. So let us consider a pool of water. Let's say initially all the water is at rest. There is no uh, disturbance applied from the outside in the water is at rest, at steady state, at rest. Okay, then if we throw a stone from outside, what happens? When we throw the stone, we applied a energy with it, right? When we throw it to the water, we apply apply a external energy with it. Then when the stone hits the water, the energy it carries with it will transfer to one particle to another, one particle to another in the water. So that energy will transfer from one particle to another like a wave. This is in the form of a wave. So that's how wave occurs. See the particle when the stone hits the water, the particles of the water do not change its position from one point to another. Only the transfer of energy only the energy transfer from one point to another. The particles of the medium do not change its position. It may vibrate for some time, but it do not change its position. So you can write down that wave can be described as a disturbance that travels through a medium from one location to another location. A wave can be described as a disturbance that travels through a medium from one location to another location. So, uh, so basically, wave is a disturbance that travels. Wave is a disturbance that travels. Okay. Okay. So these are some characteristics of wave. Uh, so the first one is the particle of the medium traversed by a wave execute relatively small vibration about their mean position, but the particles are not permanently displaced in the direction of propagation of the wave. So, if we take the example of the stone and water, when the stone hits the water, it transferred energy to the particles of the medium, right, or the particles of the water. The stone will transfer energy to the particles of the water. The particles will not change in position, but it vibrates in its own position. Vibration means it may go upward or downward, or it can go forward and backward, but eventually it comes back to its own position. So that means the particles of the medium will vibrate in its own position when the energy is transferred from one particle to another. See, in case of wave, there may be two kinds of vibration may occur. In one kind, the particles will go for upward and downward, then comes back to its own position. And in case of other vibration, the particles may go forward and backward, and again eventually will come back to its original position, mean position or original position. Okay, so the second characteristic is each successive particle of the medium executes a motion quite similar to its predecessors along or perpendicular to the line of travel of the wave. So successive particles mean adjacent particles, the nearest particle. Okay, so first first there is a original point now, so from where the all the particles will get the energies, or all the particles will the origination the origin of the wave. So from there the particles of the medium execute similar motion. The vibration would be similar. If they are vibration along the wave, then if one particle vibrates along the wave, then all the other particles will vibrate along the wave. If the original particle will vibrate perpendicular to the wave, then all the other particles will vibrate perpendicular to the wave. So that means the all the particles will vibrate in a similar motion. See, I already told you that there may be two kinds of vibration. One is uh, upward and downward, that is perpendicular. Okay, that is perpendicular vibration. So in that case, if the original particle will vibrate perpendicular direction, then all the particles will vibrate in perpendicular direction when energy is transferring from one point to another. Again, if the original particle means the first particle which will get the energy. If the original particle will vibrate along the wave, that is the second kind of vibration, which is forward and backward. Then all the other particles will travel along the wave. So that means the in case of wave, all the particles of the medium execute similar motion. All the particles of the medium execute similar motion. Okay, so during wave motion, only transfer of energy takes place, but not that of a portion of the medium. So that part I already told you. Only transfer energy with it, not the particle of the medium. The particle will vibrate in its own position. Okay, any question up to this? Any confusion? तुम लोगों को समझ में आ रहा है कि नहीं आ रहा है? कोई रेस्पॉन्ड तो करो. अगर आ रहा है फिर भी बोलना चाहिए ना. Why you are not
समझ में नहीं आ
responding
रहा
anything? हाँ? Yes?
मैम, समझ में नहीं आ रहा मैम.
समझ में नहीं आ रहा है कौन सा पार्ट?
मैम पूरा होल टॉपिक मैम समझ में नहीं आ रहा
होल टॉपिक समझ में नहीं आ रहा है. ओके
मैम.
ओके ओके. एनीवन एल्स? और किसी को समझ में नहीं आ रहा है?
মেম ময়ো বুজি পোৱা নাই ভালকে.
ভালকে বুজি পোৱা নাই? আচ্ছা ঠিক আছে.
আপুনি অলপকে বুজাই অলপকে বুজাই দিব.
অলপ অলপকে বুজাই দিব লাগে?
হয় মেম.
আচ্ছা ঠিক আছে. Okay. So basically, if someone asks what is wave, then you have to answer wave is a disturbance from equilibrium position which travels. You have to mention that point that wave travels. So wave is a disturbance from equilibrium position which travels. See, initially particles of any medium is at rest. When if we don't apply any external force or external thing to the medium, then all the particles are at rest. Initially all the particles are at rest. Then if we apply a disturbance can be any force, pressure, etc. Force, pressure, etc. can be disturbance or energy. So if we apply any energy from outside, the particles of the medium execute a motion that not the particles of the medium, a motion executes on the medium, that is the wave. See, अगर तुम लोगों को मैं बोलूँ कि अगर एक पूल में पानी है और उसमें हम एक स्टोन वहाँ पे फेंक देते हैं, तो क्या होगा? एक वेव होगा ना, एक मोशन होगा. वही है वेव. तो पहले तो पानी सब स्टेडी स्टेट में था ना, वहां पे कुछ नहीं हो रहा था. इफ वी अप्लाई एक्सटर्नली तभी वहां पे वेव क्रिएट होगा. वहां पे तो खुद ब खुद वेव क्रिएट नहीं होगा ना. वेव क्रिएट करने के लिए हमें एक्सटर्नली एनर्जी देना पड़ेगा. एनर्जी और एनी फोर्स और प्रेशर कुछ तो देना पड़ेगा, नहीं तो पानी तो वैसे ही रहेगा ना. दैट इज द डिस्टर्बेंस. डिस्टर्बेंस देने से ही वो ट्रेवल करेगा वेव. ठीक है, तो वेव इज अ डिस्टर्बेंस फ्रॉम इक्विलिब्रियम पोजीशन व्हिच ट्रेवल्स.
हेलो मैम.
यस
मैम ওয়েভ অকল পানীতে সৃষ্টি হয় নেকি?
নহয়, ৱেভ বহুত ধৰণৰ থাকে. ইলেক্ট্ৰমেগনেটিক ৱেভ, সাউণ্ড ইজ অলসো এ ৱেভ. বহুত ধৰণৰ ৱেভ থাকে, কিন্তু মানে পানীটো তোমালোকে চকুৰে দেখা পোৱা ন, তো সেইটো এক্সাম্পল দিবৰ কাৰণে ইজি হয়. সাউণ্ড ৱেভটোতো দেখা নোপোৱা ন তোমালোকে, তো পানীটো এক্সাম্পলটো মানে বুজাই দিবৰ কাৰণে ইজি হয় কাৰণে পানীটো লৈছো আৰু. ঠিক আছে, ৱেভ বহুত ধৰণৰ থাকিব পাৰে. Okay, disturbance wave is a disturbance that travels. What happens when you apply that extra energy or extra pressure or extra force into the medium? The first one particle of the medium will get the energy, right? Then it will pass that energy or force or pressure from one point to another. The first one point of the medium will get that energy, then it will transfer that energy from one point to another. See, it will send the energy from the next particle. The next particle will then send the energy from the next particle. That's how the energy travels from one particle to another. That is the wave. ओके जैसे पानी में अगर फेंक दिया तो ऐसे वो वेव क्रिएट जैसे क्रिएट होता है. द पार्टिकल्स ऑफ द वाटर विल नॉट चेंज इन पोजिशन. जो वाटर का पार्टिकल होता है वो अपना पोजिशन चेंज नहीं करेगा, वो अपने ही पोजिशन में वाइब्रेट करेगा और वो एनर्जी ट्रांसफर होगा वन पॉइंट टू अनदर. जैसे जैसे एनर्जी ट्रांसफर होगा वैसे ही वेव क्रिएट होता जाएगा. तो दैट इज अ वेव. Always remember, wave doesn't transfer the particles of the matter, it only transfers the energy. Okay. So characteristics, the first one is the particles of the medium will vibrate in its own position. When the energy get the particle will vibrate in its own position. That means vibration can be two types. One is perpendicular direction, one is perpendicular to the direction of wave, and the other one is along the direction of wave. When the it will vibrate in the perpendicular direction, it will vibrate upward and downward and eventually comes back to its own position. And again, if in case of along the direction, the particle will move forward and backward and eventually come back to its own position. So these two kinds of vibration happens to the particles, but the particles do not completely change its position. The particles do not travel with the wave, only the energy travel with the wave. Okay, next point is same, that all the particles execute similar motion. And the last one is which I already told you, that only the transfer of energy takes place. Okay, अभी समझ में आया तुम लोगों को? बोलो.
समझ थोड़ा थोड़ा आगे समझ में आया.
थोड़ा थोड़ा समझ में आया. यस
मैम
यस.
मैम আমি এইবিলাক নিজৰ ভাষাত লিখিব পাৰিম.
নিজৰ ভাষাত লিখিব লাগে.
You can write this.
শুনা মই
নিজৰ
শুনি
ভাষাত
আছো.
লিখিব পাৰিম.
পাৰিবা নিজৰ ভাষা লিখিব পাৰিবা কিয় নোৱাৰিবা কি লিখিব খুজিছা
মেম এইবিলাক মানে অলপ ডাঙৰ আছে তো সৰু কৰি
সৰুকেইটো দিছো যিমান পাৰো মই মিনিমাইজ কৰিয়ে দিব চেষ্টা কৰিছো হা হা শুনা নাই কি
মানে
কৈছা
যিখিনি পাওঁ মানে চব হেল্ল'
তুমি তোমাৰ কুৱেশ্যনটো চাট বক্সত লিখি
মেম যিটো প্ৰথমটো আছে
হা হা য়েছ
হেল্ল' মেম যিটো প্ৰথমটো আছে
হা
কেৰেক্টাৰ
হা হা
suppose আমি এইটো আমাৰ নিজৰ ভাষাত suppose মই এনেকে লিখিলো particle vibrates along its own position without without any displacement
yes yes you can write like this yes লিখিব পাৰা তেনেকে
thank you ma'am
ওকে মানে তুমি সেন্টেন্সটো সিম্পল কৰি
আৰু
লিখিব
মেম
খুজিছা ন yes কোৱা
yes ma'am yes
কোৱা কি সুধিব খুজিছা
আৰু মেম ইয়াতে পাৰ্টিকল যিটো আছে হেল্ল' মেম
শুনি আছো
ইয়াতে পাৰ্টিকল যিটো কৈছে তুমি পানীৰ পাৰ্টিকল যিটো কৈছে এইটো মানে গছৰ পাত যে থাকে সেইটো আমি এক্সাম্পল হিচাপে ল'ব পাৰো
পাৰ্টিকল তুমি গছৰ পাত বুলি
হেল্ল'
এক্সাম্পল ল'ব নোৱাৰিবা
মেম গছৰ পাতটো চেম হয় উইথআউট এনি ডিসপ্লেসমেন্ট এইটো নাযায়
হা 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 এক্সট্ৰা ফ'ৰ্চ নিদিয়াকে যে ট্ৰেন্সফাৰ নহয় সেইটো ক'ব খুজিছা ন এনাৰ্জিটো
ইংলিছ মেম
হা
এইটো
হা
ভাইব্ৰেট
হা
হয় এইটো
যেতি
ভাইব্ৰেট
হা
ৱেভটো প্ৰপগেট হৈ থাকে
হা 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 য়েছ
ওকে মেম
ওকে
ক্লিয়াৰ ন মেম
okay okay so now types of waves basically there are two types of waves transverse wave and longitudinal wave কোনোবাই কিবা সুধিব খুজিছিলা নেকি
মেম আমাকতো নোটছ দিব এইবোৰৰ
নোটছ দিম কিন্তু মানে এতিয়ালৈকে তোমালোকে মানে স্লাইড কেইখনৰ স্ক্ৰীনশ্বট মাৰি লৈ লিখিব পাৰা গোটেইখিনি বুজাইয়ে দিছোতো তোমালোকে স্লাইড কেইখনৰ স্ক্ৰীনশ্বট মাৰি কিনেও লিখিব পাৰা নোটছতো এইখিনিয়ে থাকিব বেলেগ একো নাথাকে হা
মেম তেনেহ'লে প্ৰথমৰ পৰা দি দিয়ক স্ক্ৰীনশ্বট মাৰি লওঁ
হা হা দিম একেবাৰে ক্লাছটোৰ এণ্ডত দি আছো ঠিক আছে
আচ্ছা আচ্ছা মেম থেংক ইউ
ওকে Okay, so now types of waves. So basically there are two types of waves, transverse waves and yes,
It's not clear the screen.
the screen is not clear.
yes
No,
ma'am
ma'am.
Okay. Is it clear now?
Ma'am. Yes, ma'am.
Okay. Okay, so two types of wave, transverse wave and longitudinal wave. See, transverse,
दिखाई दे नहीं
কি কলা? Saurabh Devnan,
जूम कर दो मैम
zoom out. What?
জুম मैम চাব পৰা নাই এইটো ভালকৈ ৱৰ্ড কেইটা
Word কেইটা
ডাঙৰ কৰি দিয়ক
চাব পৰা নাই আকৌ ডাঙৰ
অ
কৰি দিওঁতে ক'লে দেখা নাই বুলি এতিয়া দেখিছানে
তাৰ হি নেটৱৰ্ক প্ৰব্লেম হ'ব মেম আমাৰ দেখাই দি আছে
তুমি দেখিছানে
দেখি আছো
এতিয়া
মেম
আচ্ছা ঠিক আছে
অ
যোনে যোনে দেখা
তাৰ
পাইছা
নেটৱৰ্ক
ন
প্ৰব্লেম হ'ব
যোনে যোনে দেখা পাইছা ন স্ক্ৰীনশ্বট কেইটা লৈ কিনে গ্ৰুপত শ্বেয়াৰ কৰি দিবা হা যোনে
অ
দেখা পাই আছা স্ক্ৰীনশ্বট লৈ গ্ৰুপত শ্বেয়াৰ কৰি দিবা okay so these types are divided according to the types of vibrations. See, I already told you that there are two types of vibrations in the particles of the medium. So according to that, these types are there are two types. So one is transverse wave, one is longitudinal wave or longitudinal wave. So in transverse waves, the particles of the medium vibrate at right angles to the direction in which wave propagates. Right angles means perpendicular, upward and downward motion. That upward and downward motion is perpendicular or right angles. So transverse waves, the particles of the medium vibrate at right angles to the direction in which wave propagates. So example of transverse wave is waves on strings, surface water waves, electromagnetic waves. These are the example of transverse waves. Again, in longitudinal wave, the particles of the medium vibrate along the direction of the medium, or that forward and backward motion, that is along the direction of the wave. So in these types of waves, the particles of the medium vibrate through and fro. To and fro means forward and backward. About their mean position along the direction of propagation of energy. So along the direction of the wave, the particles vibrate. These are also called pressure waves. So always remember, longitudinal wave also called pressure wave. So example of longitudinal wave is sound wave. So sound wave is an example of longitudinal wave. Okay, so next one is properties of wave. Properties of wave, there are five properties: amplitude, wavelength, time period, frequency, and speed. So amplitude means the height of the wave. Okay, amplitude is the height of the wave. Uh, when the particles vibrate, up to which the particles can vibrate is the amplitude. যেতিয়া পানীৰ ঢৌবিলাক দেখা পোৱা, সেই ঢৌবিলাক কিমান ওপৰলৈ যায়, সেইটোৱে হ'ব তাৰ এম্প্লিটিউড. Okay, next is wavelength. Wavelength means in one vibration, the distance traveled by the particles in one vibration. That is the wavelength of the wave. The distance traveled by the particles during one vibration. এটা vibrationত কিমান distance travel কৰিলে, কিমান ওপৰলৈ গ'ল, কিমান তললৈ গ'ল, এইখিনিয়ে হ'ব wavelength. Time period means the time taken during one vibration. The time taken by the particles during one vibration is time period. Frequency is the number of vibrations in 1 second. Frequency means total number of vibrations in 1 second. Time period and frequency are reciprocal of each other. See, if we take time period as t and frequency as f, then f equal to 1 by t and t equal to 1 by f. So time period and frequency are reciprocal of each other. The next the next property is speed. We already know that speed is distance by time, right? Distance by time is speed. Here distance is taken as wavelength and time is taken as time period. Therefore speed of the wave equal to wavelength divided by time period. Speed of the wave, wavelength divided by time period. Okay, take screenshots from the beginning. Okay, so in the next class, I'll discuss these properties briefly. If you have any confusion regarding today's class, you can ask now. And Start giving your attendance in the start box.
Hello,
Yes.
ma'am. Amplitude is the height of the wave.
Yes.
Okay, ma'am.
Ma'am, name of the chapter?
Waves and sound. First chapter notes. I'll give you this week. I'll give you this in this week also. Okay, if your attendance is done, then you can leave.